we're going to start just with a quick review warm-up. If you look at some things that you did from 6th grade, we just talked about, when you are looking for a missing value, you have choices. You want to look for, are there easy things to do? Can you just multiply or divide by a simple factor? To get from 3 to 9, you can do that, right? You just have to multiply by what? 3. Okay, so whatever you do to the top, you could do to the bottom. So don't forget your skills that you would normally have done a long time ago. You don't have to get fancy when the problem's easy. So what we would say is 3/4 is the same as 9/12. So the missing value is x equals 12. Okay, raise your hand if you know that. Okay, so that's a review for everybody. Matthew, question?
Well, just saying, the last video you made, there wasn't any sound, and I think because the microphone's turned the other way.
Oh. No, you know what? That was I think that there is sound, actually, but I remember that. The computer guy came in and fixed something. I forgot to tell your class that, and I didn't know there wasn't any sound until later in the day. So when he fixed one thing, for some reason, all of my sound was turned off. Yeah, so guys, you should let me know ahead of time. And I'm pretty sure then all of my bars were down. And they're not now. But thank you. Thank you for pointing that out. It happens once in a while. So one thing is, make sure you could do the old stuff. And if you could do the old stuff in quick, don't make it harder. You know, you don't have to do new things. One of the things we did is you could always check for a couple of things to look for, I guess. And the reason I want you to think of these before we do the shortcut, look at the end got taken away.
Reduce the down.
Reduce the down, not a good idea. Okay. Can you take a fraction or a ratio like 20/24 and reduce it down? Because this builds your number sense before we do shortcuts. What goes into both of these?
6, 4,
4, right?
5, 6.
So this is 5, 6. So sometimes just using number skills, we could reduce down so we can then build up.
Oh, and then you can do 6 times 3 equals.
And then you can do 6 times 3 equals 18.
Oh my God, we're greater than 15.
And so this missing value then is 15. 6th grade, you should have done that. Everybody in this building should have done that in 6th grade math and 7th grade math. Now, you might not remember it, but the reason we do that is it helps you build number sense. Nadiv.
What is number sense?
So number sense is before you go to a shortcut, do you really understand what it means? Like, do you really understand why? So there's shortcuts for these problems, but before you do a shortcut, you want to make sure you understand what a proportion is. So if I tell you that this is 15, do you really understand why 15/18 is the same thing as 20/24?
Yeah.
And hopefully you do, because they both reduce to the same fraction, 5, 6. Does that make sense? So today's all about proportions, and your book is all about shortcuts, which is really good when you get into these advanced math classes. We all want to do shortcuts. It's helpful. But it's really dangerous if you don't understand what the shortcuts are giving you. You should understand there's a reason, because if you don't understand proportionality, you won't know if you made a careless mistake, if you're just following a bunch of rules. So you always want to look at your answers and say, is that reasonable? Olivia.
So for the first one, I even did it simpler, like 9 times 4 is 36, 3 times what is 36, and you can just do 2.
But that's a shortcut. Why does that work?
Because
Right, and it doesn't have as much meaning. But we're going to use shortcuts. But what I'm trying to say is, it's a really common problem, and some of you are already hitting this. Sometimes you have all these shortcuts in your head so you can do problems, but the minute I ask you like an analysis problem, you can't really do it because you never really understood what the shortcut was doing for you. So, yes, there is a shortcut, and that is the goal today. When you do a cross multiply, you can find the missing value, but my question is, what does that really mean? So how do you justify that x is 12?
If you multiply 12 times 3, that equals.
Yeah, but why does, that's just a shortcut. Really, what you're supposed to notice is that 3/4.
You reduce it.
Yeah, exactly. 9/12 reduces down to the same number. So the reason those are proportional is not because some shortcut works, but because they reduce down to the same number. And I know for a lot of you, that might not make, maybe you're not sure why I'm saying that, but I taught high school math for so long, advanced classes, and so many kids could get to this class, Advanced Algebra 2, which was really hard, and they have all these tricks, but they don't understand why any of them work, and all of a sudden, they can't memorize anymore. You guys can memorize a lot. So they're just packing it all in their head, and then all of a sudden, they have to be able to think. So just doing shortcuts doesn't really teach you to think. It's just one more thing you're memorizing. So in this unit, even though you're going to use a shortcut, you want to make sure that there is like number sense. You know, you need to understand that the shortcut is giving you a value that makes this proportional to this. And you have to understand what proportional means. They reduce to the same ratio. Okay, so I promise you, if you only know shortcuts, it'll get you through for a while, but it will backfire. It will backfire if all you do is do the shortcut because it works. You have to have understanding. It might not backfire right away. That's the danger of shortcuts. That being said, you guys are in advanced math, and once you see the pattern works, you want to start using it. So that's what I was trying to get to. If I look here, 20 times 18 is 360. Right? 15 times 24 better be 360. Because that's what the shortcut says.
That's a good check.
Well, it's actually a good method to use, but you can't rely on just shortcuts in math. You won't get good at math if all you know how to do is shortcuts, because they don't teach you to problem solve. They help you along the way. So like what Noah was saying, that's a good time to go back to his problem. What he did is actually a better understanding. He thought of this problem down here, like what was really going on. He divided, tell everybody what you did, Noah.
So I just divided how many times 20 goes into 32, the long division.
Yeah, he was just kind of thinking like, if I could break this up and see how many 20s go into 32. So what'd you get when you did that?
1.6.
So he did this, and he got 1.6. Was it repeating by any chance?
No.
Even. And so he knew for every one of these parts, they were 1.6 of these parts. And so he multiplied the 19 by 1.6. He made it proportional in his head. But if you look at the shortcut, which is why I said we're going to come back to this, he did the shortcut, but he did it because he used some common sense thinking. The shortcut tells us if we multiply these two on the diagonal, and then multiply these two, we get an equation that we can solve. And then we use our work from last semester to find the missing value. But 19, so if you look at this, he just did this first. He did 32 divided by 20. And then multiplied it by 19 parts. So in his brain, he has like a natural understanding of proportion, which is a lot different than just saying I cross-multiplied. So you want to make sure that you think about your answers, because then he probably could see if his answer was reasonable. What did you get for an answer?
I got 1.6 raised to 30.40.
You got,
Grand.
what was the
30.4 grand, parts.
and parts grand?
Or ounces.
And then we could check it, right? We could check his work with the calculator. And just do a quick check. So it would be 19 times 32 using the shortcut divided by 20 30.4, and then he could subtract 32, take away 30.4, because they have to total up to be 1 point, right?
Yeah.
Okay, one other thing I want to show you, and then I'll take a couple of questions. You should practice reducing here. Both 20 and 32 have 4 in common. That's a quicker way to multiply. So if you don't have a calculator, 19 times 8, that's the same as 19 times 8 divided by 5. When you work that out, you're going to get the same answer. Adam, are we out here at 10?
Yeah.
Okay.
So I get the, like, but I don't get any of the cross multiplying.
Right. So we're getting to that. That's the goal today, is to get to the y. Okay?
Well, I get like the number sense, but I don't understand
How to do the cross multiply.
Yeah, that's the opposite.
So give me more specifics on this problem 2. What part do you get?
It's like that chart thing, but if you did a cross multiply, like when you were doing the 19 times 32 over 20 and all that stuff, I had no idea.
So in this problem here, how would you solve it? Not sure? Really, the one thing, what Noah did was he was just thinking, let's go through it one more time. What you should be thinking is, how many times does 6 go into 20? That's really what you should be thinking. So if you did it the long way, you would just say, well, 6 goes into 20 3 times, right? And so that's 18. And so it's 3 and 2, 6, or 3.3 repeating, right? So that means you have to multiply this by 3.3 repeating. That's really what a proportion is all about. So you would have to do the same thing here. You would have to multiply this by 3, and we would want to leave it in fraction form in that case. 3 and 1/3. So you would have to take 5, and then you would multiply it by 3 1/3, which some of you still need a lot of practice. That's 10/3, right? So that's 50 over 3. Right, it's 50 over 1, you're right. And so that's, how many times does 3 go into 50? Yeah, Johnny. 16 and 2/3. Okay? So that's really what's working. I mean, that's really what is going on.
Yeah, I was just 16 2/3 over. I get that.
Yeah, so that's where, so is that uncomfortable for you guys? Right, because in 6th grade math, you never had a fraction up there, did you? This was never, ooh, not a fraction. But, okay, so the cross multiply is a shortcut for this. So what? That's exactly what I wanted to show you next. So this is really what's going on. You're doing the same thing to the top and bottom. That should make sense to you guys. That's all my concern is. That should make sense to you. But what you'll see is now it turns out there's a shortcut, because look at, if I cross multiply, if I multiply what's on the diagonal, let's bring maybe another page in here so I can write bigger. So I'm going to take that problem and write it here. 5, 6 is equal to z over 20. We just found out that that's 16 and 2/3 by using logic, by doing the same thing to the top and the bottom. The shortcut, which is easier math but doesn't have any meaning to it, is handy. So that's 100. 5 times 20 is 100. So 100 is equal to 6z. So if I divide by 6, remember that's the same as 50 divided by 3, isn't it? Which is 16 and 2/3.
You know, one with the raising, how many like you would use like in this case would it look like 5 times 20 divided by 6?
So if I wrote it in one step, that's a great question, Zig. You would say it's 5 times 20 divided by 6. I like what he's asking is practicing that reducing. Can you see 2 goes into 6? 3 times. How many times does 2 go into 20? 10. So that's the same as, right, 50 over 30, over 3, which is the same. Practice that so you're not getting giant numbers. So if I go one question, Nadi.
Can you put, instead of 16 2/3, can you put 16.666?
If it's a benchmark fraction, that's exactly correct also. Yes. So how do you say that again? How do you check it? So the way you would check to see if you did it right, let me copy this down. Pretty hard to check with messy numbers, but you want to make sure these two numbers, when you multiply, I think this is what you're asking, has the same product as these two numbers. You want to make sure. So 6 times, and remember this is 48 plus 2, 50 over 3. We want to check to get that we get the same number. And we could do just what Zig was asking about again. 3 goes into 6 twice, so that's the same as 2 times 50 over 1. So you check, it should multiply out. The logic one has a lot more meaning. Sometimes the numbers are so messy, the shortcut is nice. So I'd say be flexible, because you will eventually just be able to do both. So in your homework, these are the choices. Reduce all fractions is using logic, right? You're gonna solve proportions in your homework. You can use the shortcut, which is the cross product. This is a shortcut, but you should also just don't forget your common sense thinking, because I can tell you after years of teaching, kids that use shortcut, they may look better on paper for a while, they may get a few higher test scores, but in the long run they don't. Okay, because they don't know why they're doing anything. So you want to do both. So when the shortcut is natural, what are we doing here? Multiplying by 2, so going backwards we would be, so if we go backwards we have to divide this by 2. Don't forget logic. Now if you want to use the shortcut, the cross product, look how much more work it is. 7 times 12 is equal to 14 times x, divide by 14. Now reduce, 2 goes into here, so 7 times 6, and 7 goes into itself once, and you eventually get 6. But if you just thought about the problem, don't forget you already know stuff. So when it's easy, keep it easy. When it's not, then do the cross product. 5 times 63 is equal to 8b. Do you see the benefit of the cross product? Because then you would divide both sides by 8. Okay, so before you pack up, in this type of problem, 63 and 8 have nothing in common. So you can try to do as much work by hand, but if you need to do a little calculations today, that would be fine on the calculator as long as you show your setup. So 5 times 63 is 315 divided by 8, and then go ahead and get a decimal answer there for today. 30.375. Okay, one more thing, guys. Back to your seats. It's not quite time. Have a seat. So that's the beginning of the thinking. You have to understand the wording of the questions. So your textbook will ask you if things form a proportion. So for something like this, you could just think of it the way I had it written. Do they reduce to the same thing, or are the cross products the same? In my opinion, and I bet for a lot of you, it'd be quickest just to see by reducing first. It's always quicker to use small numbers. This is the same as 3/4, and that's the same as 3/4. If you use the cross product there, it's going to be giant numbers. On this one, cross product is quicker. 5/6 is equal to 4/5. Is 25 equal to 24? No, so the answer to this question is these do not form a proportion, but these do. Right, but I want you to see that there's a reason we don't always just do cross product. Reduce sometimes, cross product other times. I think if you take a look at the book, they do some nice setups too. So that's about it for today.